So, good morning, everyone, and welcome to today's class. This is lecture number 6, Units and Dimension. And today, as students are telling me, is Teachers' Day. And on this Teachers' Day, I would tell you something that I truly believe in. This is something that I believed in from first day since I started teaching. That was way back, probably in the year 1994 or 95. Not 95, 96 maybe, when I was preparing for JEE, and I used to teach my not teach discuss with my fellow friends and companions. And after I cleared my JEE, when I used to come back from college, I used to take classes of all these juniors around me. I used to always tell them from that day onwards, I used to tell them one thing that I believe in, that a student is always smarter, brighter than a teacher. A student has to be smarter and brighter than a teacher. That only tells how good the teacher was. If the teacher is more smarter than what you are, or in your case, if the teacher can solve the sum faster than what you can, that means that teacher is not good enough. That means there has to be an improvement that has to be made. There could be problems where I get stuck, as I did not know how to make the co-host, but the student should not get stuck. So a student should be brighter than his teacher, and that is always the case. You take the example of any student teacher combo, and you will always find that the teacher somewhat lacks the student, even though how brighter the teacher may be or how dumb the student may be. The student should always be, is always more intelligent, brighter, sharper, smarter than the teacher. Arjun and Drone, well, Arjuna probably was better than him. The only thing is, maybe Drone did not tell him one thing that might be helping Arjuna in defeating him. That is a different thing. But Arjuna was way brighter than his Guru Drone. On that note, let us start with today's lecture. And I believe that you will be smarter than me. And that is the only intention that I am teaching you. We were dealing with units and dimension, and I think we were dealing with the third use of units and dimension. We are going pretty slowly. We'll have to pace up since the sections have also changed. We'll have to pick up a bit of a pace. We were dealing with what are the uses of units and dimension, and we had come into the third use of unit and dimension to check the correctness of an equation. And we had seen that if the equation is correct, it would be dimensionally correct.
Can you explain about question paper? Yesterday's question paper.
Yes, beta.
Yesterday's question paper. Can you explain?
Yesterday's question paper, I did not get the question paper. Only 4 questions were there. Was it a difficult one? I do not have the paper, beta. So we'll discuss it in the coming class. There are only 4 questions in that paper. You could not solve them? Which question you could not solve? Tell me. I don't have the paper, beta. Tell me which question you could not solve. Do you have the question paper with you? Can you tell me which question you could not solve? Yes? No? Tell me. Which question probably? Tell me which question. Read out the question. Can you? Read out the question. Which particular question are we talking about here?
25th question, sir.
Yes, beta. See, don't tell me the number. I don't know where it was. So read the question. I don't have the paper. I don't have the number. So you just tell me the number. It's all Hebrew for me.
This can be used to derive which of the following relations?
Okay, that is what we are supposed to do today. But that doesn't mean that you could not have done it on your own. There are always questions in an examination hall, and that is why the question was there, which you may think that has not been covered, but it is already covered. Okay, so which relation cannot be determined using dimension analysis? Can you read the formula? Can you read the options? Can you read the options? Which equation cannot be determined using dimension analysis? Now I ask you to read the formula for it. What are the 4 equations or 5 equations that are given? Tell me. Yes, bacha?
I'll say the options, sir. 1 minute, sir.
N0 e power minus lambda t a.
I'm sorry, I'm not able to make out, beta. Just give me a minute. Maybe I have that. Whatever I send, maybe I would have that. Let me just remember that I had saved it somewhere. Units and dimension. Okay, that is probably the paper that I sent you. The method of dimension analysis cannot be used to determine which of the following relations. Then you had 4 options. Option number A and not e to the power minus lambda t. Then option B was a sine something. Option C was half I omega square plus something something. Option number D was none of these. This is the question that you are talking about, beta?
Yes, sir.
Yes, sir. So tell me, sir. We have not covered this, sir. We are going to cover it today, sir. But this was a question for higher level understanding whether you can do something on your own if it is not being told to you. So, what do you think is the answer? Remember, you could have just used whatever we have learned from the 3 classes and used it in this question. Now, which equation cannot be determined from here? And I told you that something does not have any unit and dimension and you cannot find out. And we had done this question, not exactly this question, but yes. See, what is right on your board is the answer to what the question was asked. Option number A here. You look at option number A. This equation was correct, yes or no? Do you see this option? This equation was correct, yes or no?
Sir.
Yes, sir. Now look at the other equation, sir, that we did, sir. Option B. This equation was wrong, sir. Yes or no, sir? What is the difference between the two equations, sir? Because this equation had this term, sir. And this term created the problem, sir. Yes or no, sir? Now, that is how you will be able to solve question in JEE Advanced. Because the same question that I am going to do, the probability is there that that same question will come in the exam. Last year, I mean this year it came. The same question that I did in the crash course came in the exam. Last year it came. Last year it came. But maybe 1 or 2 questions will come in the entire 36 questions. Questions will be coming from what I have taught. Now, this option is wrong because 3 by 2 is the problem. First option was correct because 1 by 2 was correct. That means 1 by 2 and 3 by 2, it cannot be determined by dimension analysis. Yes or no? Numbers do not have dimension, so you can put any number and the problem is there. Now look at the options that you have and tell me what is the equation that cannot be determined using dimension analysis. Which equation cannot be determined using dimension analysis? Whatever equation that has what? Whichever equation has what? That cannot be determined using dimension analysis. The answer is right there. Which has? which has?
Mathematical numericals.
Yes, that equation cannot be determined. Did you know it or not? That numbers do not have dimension. If number comes, you will not be able to use dimension analysis. Yes or no?
Yes, sir.
That is the answer, sir. That is the answer, sir. Equation number third had half
Sir.
and half. You cannot determine it. That is first reason why you cannot determine it. The second reason I will give you in this class. But you had one reason and you had to apply your brain. And that is the reason why this question was given. And I think the question has served its purpose. Anyone could do this? Anyone could do this? Anyone from any class? Please raise your hand.
Yes,
That's
sir.
sir, I
None
was
of
able to do it.
this.
Yes, beta?
None of this, sir.
None of these, sir. Koi baat nahi, sir. This is the way you learn, sir. Remember, physics only teaches us concepts. Now, how are you going to apply those concepts will have to come. And how does it come? You do a lot of questions. You do a lot of questions. You will encounter different types of questions where the same concept is applied. Same concept is applied. Now, once you do all these large number of questions, you will be able to solve them. And that is the basic premise of doing good in physics. Do we understand this? Just remembering a formula S is equal to UT plus half AT square is not going to serve any purpose because that you have done in 9th standard. In 11th standard, you will have to understand where and how I can use this. The question may not straight away ask, give me the displacement. No, they will not ask the straight question. They might ask the same thing in a different way. That is where you have to be smart enough. Is there any other question that has troubled you? Yes or no? No, yes. So, shall we move for today's class then? Shall we move ahead? Okay. So, we saw that if an equation is correct, it has to be dimensionally correct. That means if an equation is dimensionally correct, it may be correct, but as you see, in this case, 3 by 2 comes into the picture. 3 by 2 is the number. You cannot determine it using a dimension analysis. And hence, even if the equation is dimensionally correct, it may be wrong. So dimension cannot help you. And we will write this as a point after the end of everything. Dimension cannot help you wherever you have numbers. Will you remember it now from this question? And you will never forget it because you could not solve the question. Yes or no? Yes, and that is what you need to learn as well. If there's a question that you could not solve, just because you could not apply a concept, it's good that if you are not able to solve that question, because then you will always remember that concept. Oh, sir, that question I could not solve, and that was the concept. So it's also important not solving, not able to solve a question is also going to serve a purpose. Do we get this? It's not always that you solve a question and you understand the concept. Sometimes you are not able to solve the question and you are able to understand a concept because no one remembers the good work that you have done. No one remembers how good or how correct you were when you did 10 or 15 or 20 things correctly. They will always remember one thing that you did wrongly. And that is how human psychology works. There is a very famous example of, since it is a teacher's day, there is a very good example of Albert Einstein teaching, and he wrote something like this. I may not be exactly remembering. He wrote something like this. He kept on writing this, and I hope I am correct with the equation. He kept on writing this. He kept on writing this. Now, he asked the students after he had finished writing, which I am going to do now. What do you think about
Sir,
what do you think about my knowledge?
sir 9 9 81 no sir.
See, that is the problem. You never saw that sir has written 9 equations correctly, but you definitely saw that sir, this is wrong. I've got you. That is the problem, and that is human psychology. So if you're not able to do something correctly, people will point it out, and you will also remember, "Arey, I did it wrongly. I could not do it, or I did it wrongly." And that is how sometimes even making a mistake helps us in understanding a concept. And this question was the best example I could have done in the limited things that we have studied. Shall we move ahead? Okay. And that was the exact answer everyone in the class gave to Sir Albert Einstein. Sir, you made a mistake there. And he told me, "Oh, I did 9 questions correctly. You did not see that. You did not praise me for the 9 correct things I've written, but you pulled me up for one wrong thing that I've done." That is how life works. Okay. So if an equation is dimensionally correct, it may be correct, it may be wrong. If an equation is wrong dimensionally, it has to be wrong otherwisely as well. Now we are going to see its uses. Now we are going to see its uses with the help of some examples. So comes example number 1. I am given an equation f is equal to mv square by r. I am given an equation f is equal to mv square by r. What does f stand for?
Force.
F stands for force, m stands for mass, v stands for velocity, and r stands for radius. Everybody understands this, or I have to write it? M stands for mass, v stands for velocity, r stands for radius. Tell me, is this equation correct or is this equation wrong? Now, I suppose that you don't know whether this equation, what anything about this equation. If you know it, that's the information that you already have, but you will have to do it by what you have learned in this class. So you have to apply that concept, because now the next question I probably will give you an equation that you have not seen. So that is why it is important for you to do it with your own hands right now. Is this equation correct? What do you think about this equation? Is this equation correct or is this equation wrong? Is this equation correct or is this equation wrong? What can you say using what you have learned in dimensional analysis? And you will see some really great problems, difficult problems coming from this particular small thing. The problem only here is that you may not be knowing the terms that are coming there. Therefore, I'll have to search for a problem. Don't worry, I'll do it in a different way. Yes, bacha. Yes, my dear friends. Can this equation be correct or is this equation definitely wrong? I need.
Wrong, sir.
This equation is wrong, sir. And why do you think that this equation is wrong? You have to tell me. You. You have to tell me the reason behind it. Yes, bacha. Tell me the reason behind it. Why it is wrong? Or right? Or maybe right? Or maybe wrong? Or definitely wrong? Yes, bacha.
So dimensionally, it is correct, sir.
Dimensionally, it is correct, my dear friend. That is correct. And therefore, this equation may be correct. It may be wrong. Are you getting my point? This equation may be correct. This equation may be wrong because you do not know whether the constant term is correct or not. This equation is dimensionally correct. Now I have to ask, why did you feel that it is wrong? It is not wrong. How do you check it? You check dimension on both sides. This gentleman is force. What is the dimension of force?
M1 L1 T minus 2, sir.
MLT minus 2. You don't have to say 1 beta. You can just simply say M. MLT minus 2. Now look at the dimension on the right hand side. What is the dimension of this gentleman? M is mass. So it has a dimension of M. Yes or no? Arey, did I lose you? V is velocity. What is the dimension of velocity? It is LT minus 1, but this is squared, so I square it. Let me put this in brackets so that it looks good. Divided by R is the radius. Radius is distance. What is the dimension of R? The dimension of R is L. Now you check the dimension on the left hand side and you check the dimension on the right hand side. Are they matching? Yes or no? No or yes?
Sir, dimensionally, yes, sir.
Dimensionally they are matching. So dimension on left hand side and dimension on right hand side. Oops, my equal to is not looking good. Let me make it better. Dimension on left hand side and dimension on right hand side are matching. So this equation may be correct, may be wrong. Why we are saying maybe? Because we do not know if there is any constant dimensionless term. And now I am giving you this information that dimensionally it is correct. It is also actually correct. This in fact is the formula for something known as centripetal force. Have you heard this term, centripetal force? Have you heard this term, centripetal force? This is the formula for centripetal force experienced by a particle when it is moving in a circular motion. And this is exactly correct equation. There is no constant term or no term with no dimension. If you call that term, that will be 1. So constant term is 1. And this is a correct equation. Do we understand this? Do we understand how we have used this concept that we have learned? Can I have raised hands from everyone in the class that we have learned this? Well done. I'll give you a minute and then I will move on to, as I said, this probably someone might have seen this formula, but then I can make ulta seedha kuch bhi formula and then I would ask you whether it can be correct or it is wrong or definitely wrong or maybe wrong. Remember the question and how it is framed. I hope you have noted down this question. Can I move on to the next one, my dear friends? Yes, sir. No, sir. Okay, sir. So I move on to the next one, and this is the equation that you got to check. Here I have written an equation P is equal to, and I am just using it from a question that has come in JEE, FV square by pi square T square X. Now, first of all, you have to understand what terms means what. I will ask you that. What does P stand for? I found out a question where you know all the terms. What does P stand for?
Pressure.
What does F stand for?
Force.
V,
Velocity.
T,
Time.
X.
Distance.
3 and pi are numbers. Do you understand numbers, right? You have to tell me whether this equation may be wrong, may be right, definitely wrong, whatever you know. Now, you will not ever get an equation of pressure like this. So, whenever you get such question where you have no knowledge and they ask you the formula, what can be the formula? That is the biggest hint for a question based on dimensional analysis. And you will definitely find a question of dimensional analysis in JEE Main and Advanced. As I told you, a question definitely came this year also. I'll be giving you that question, don't worry. The only problem is you may not be knowing the terms that are coming in that equation because we have not read those terms. So I'll just make my version of that question and then I'll ask you to solve it. Anyways, is this equation wrong, definitely wrong, maybe right? I leave it to you. Remember, this is how questions are framed in a JEE. This is how questions are framed in a JEE.
Wrong, sir.
Maybe wrong, definitely wrong. Tell me that one, beta.
Definitely wrong, sir.
Definitely wrong, sir. And why do you think so, sir? There must be a reason why you think so, beta.
Not equal.
Yes, bacha? Sorry, I missed your voice. Are the dimensions matching?
Sir.
Dimensions are not matching. If the dimensions are not matching, you can say with authority, with confidence, that this is definitely a wrong equation. Let us go about and check the dimension. What are the dimensions of P? See, that is not good.
M1 L minus 1 T minus 2.
Okay. ML minus 1, T minus 2. Let us move ahead. Remember, we don't have to think about 3 and pi square because they are simply numbers. Let us forget them. Let us talk about this F gentleman. What is the dimension of this F gentleman?
MLT minus 2.
MLT power minus 2.
Well done. We have to be quick now. MLT minus 2. I put it here. What about V? We already know it. Yes.
LT minus
M power
1.
2 L minus 2.
Yes. LT minus 1. Quickly. Squared divided by. Move on. T.
T square
T square.
L.
Well done. T squared. Let me put this in a this. And X is L. You
L.
can just do plus minus multiply divide. Yes or no? I hope you can do this. And you can find out whether the
M power
dimensions
3
are
T
matching
power.
or not. Are the dimensions matching?
No, sir.
Dimensions are not matching. That means this equation is definitely wrong. It cannot be a correct equation. So this equation with confidence is definitely wrong with a big cross. Anyone has any problems in understanding this? Please raise your hands. If you have done this, then I will move on to the next problem. And this is how you have to understand problems are framed in a JEE. And since you are in the JEE class, the level of questions might go up. But remember, whatever questions we are doing, similar question is going to come in your examination. Oh, and I hope that you are sharper than me, brighter than me, intelligent than me, and you will be able to solve it. Can I move on to the next one?
Yes, sir.
And this is how question come in a JEE. And I won't say anything. See, it's difficult to find out a question where all the terms that appear in the question are known to you. There are many questions which have come in JEE, but the only thing is you don't know the terms, so I just can't use them. This is the question that I found out. The largest mass M that can be moved by a flowing river depends on velocity V, density rho of river water, and acceleration due to gravity G. What is the correct relation? Yes, bacha. Now, right now we are doing this question from whatever we have learned up till now. Maybe in the next class we'll be doing the same question, but probably in a slightly differently. Still using what we have learned up till now. Yes, bacha. What you got to do? Anyone? What is the hint to solving this question? You just have to check which equation is what? Which of the following equation is
Correct.
dimensionally correct? That may be the formula because they have used this proportional sign. Now, whenever you use this proportional sign, that means there is a number which we are not concerned about. We're just concerned about the powers, nothing else. You just have to check the dimensions of the different equations. Whichever equation is dimensionally correct, that would be your answer. Yes or no? No or yes? So now can you tell me which one is the answer? Which one might be the answer? Let me do one part for you. What is the dimension of M? Dimension of M is M. What is the dimension of rho? What is the dimension of rho? Rho is density, yes or no?
LT.
Rho is density, my dear
LT
friends.
power this one.
Rho is density, my dear friends. It is ml minus 3 mass per unit volume. Did you forget it? Multiplied by V. What is V? V is velocity. LT minus 1. It is raised to the power of 4 divided by G square. G is acceleration due to gravity. LT minus 2 is the dimension of acceleration. Yes or no, my dear friends? Square. Are we getting this? Yes or no?
Sir.
Will this give me the dimension M on this side? Definitely not, because here, as you can see, M is already squared and M is not getting cancelled. Yes or no? No, yes.
Sir.
So this option has to be definitely wrong because this is dimensionally wrong. Are we getting this? You just have to check all the dimensions. Whatever equation is getting dimensionally correct, that is what will give you the answer. This was option number A. Option number A is definitely wrong. And now you do option number B. On the left hand side, I have M. On the right hand side, I have rho. Rho has dimension of ml minus 3. It is not squared, so good. Then we have velocity raised to the power 6. LT minus 1 raised to the power of 6 divided by G is LT minus 2 raised to the power of 3. Is this equation going to give me the dimension of M? Yes or no? No, yes.
Sir, power 2 no, sir.
Oh. Mistake. Genuine mistake. I did not see it. I probably saw the other term. Squared. Is this going to give me the dimension of M? Yes or no? No, yes.
No, sir.
No,
It's
sir.
not going to give me the dimension, and therefore this option is also wrong. But if this was not square, if I change this square into 3, So instead of square, it becomes cube, which is the last option. Instead of square, it becomes cube, which is the last option. Then all the things will cancel out. Yes or no? Only m will remain. And therefore, my dear friends, option number 4 is your correct option. Are you getting my point? How I've done this?
Yes, sir.
Can I have raised hands from everyone in the class that I have done this? Great. This is how questions are framed in a JEE. Now, you might have to solve all the options and get your answer, or you're not going to get this much time in the examination hall. You have to be quick and smart. Quick and smart. As I keep on telling you, JEE is all about what? It's all about speed. It's all about speed. If you can do the question quickly, you would be able to score higher in the examination hall. Are we getting my point, beta? Shall I give you one more? Yes or no? Okay. I hope you have written this one. I'll give you one more. Remember the way questions are framed in a JEE. You'll have to understand them and then solve them. You have to understand them and solve them. I hope everyone is ready for the next question. I hope everyone is ready for the next question. And here comes the next question for you guys on your screen. So you have 4 options here. Option number 1, option number 2, option number 3, and option number 4. Now look at the way question is framed. A boomerang has a mass m, surface area a, radius of curvature is r, moving with a velocity v in air of density rho. In air of density rho. You have to find out which is the force, which option is the force acting on it. You have absolutely no idea about the force but you can still find out which option may be correct. That is the power of dimensional analysis. That is how these questions will not come in a JEE Main probably. Maybe a question of JEE Advanced or somewhere between JEE Main and Advanced. If JEE Main is tough, probably you will get this. If JEE Advanced is easy, I mean, a same question came in JEE Advanced this year. Not same, similar. We'll do that, don't worry. So this is the next question. Which one may be correct? So basically what you got to see, you look at the options and that is how you solve this question. You look at the option and you find out which option may be dimensionally correct. And I'll give you time. I want you to do this question on your own without any help. because all terms are known to you. You know mass, you know area, radius of curvature, whatever you call it, R, you know this. Velocity is V, density is rho. You all know these terms. If you know these terms, you should be able to get the answer. There are still many questions, but we can't do them right now because we do not know the terms. That is the only handicap that we have. Yes or no? No, yes. Anyone with an answer? I'm waiting for you guys to give me the answer. I hope everyone is trying to solve this question. You have to check the dimension. That's all that is required. Shall I do it?
Hard, sir.
Third, sir. Well done, sir. That is the correct answer, sir. This is probably a formula for force acting on this. Just tell me, bit, how did you do it?
Density ml power -3.
Yes. So basically, what you do, beta, is here you have to just find out which is dimensionally correct. Now remember, now this is how you become smarter, and I'm going to give you a small trick. And this trick would have worked in your JEE Advanced ka paper because this JEE Advanced ka paper was very long, very lengthy, and you had many options. But if you are smart enough, and that's what I call smart hard work, you could eliminate some options. Now you have got 4 options over here. I hope everyone is attentive. Now you're not going to solve all the 4 options. How you get smarter? Basically, what you need, what you understand is whatever I am putting in green, they must be dimensionless. Yes or no?
Yes, sir.
Because it is inside log, it has to be dimensionless. You see 3 different terms here. This is term number 1, this is term number 2, and these 3 are same. Yes or no?
Yes, sir.
Third and fourth term inside are same. Now this has to be a number. Whatever I am painting in blue, the dimension of force must come from here. Yes or no? Now if you look at this one and this one, this one, and all of these 4 terms are different. Yes or no? 1, 2, 3, 4. All of these 4 terms are different. So don't have to check the green one. Only check the blue one and see which term is giving you the dimension of force. Are you getting my point? You don't have to check the green term. You can only check the blue term and you are done because all the 4 blue terms are different. You check the dimension of blue terms and you will get your answer. I will do part number 3, and then I'll do any one of those. Part number 3, if you look at the dimension of part number 3, 2 does not have dimension. Do not worry about that. Rho is density, so dimension is ml minus 3. V is velocity, dimension is lt minus 1. A is area, dimension is L square. Let us check what dimension are we getting from here.
Sir, velocity whole square.
Yes, beta, velocity is squared, sorry. Let us see what dimension are we getting from here. We are getting M L T minus 2. This dimension matches the dimension of force. This dimension matches the dimension of force, and hence option number 3 is your correct option. If you solve any of the other ones, they definitely will not be. They definitely will not give you the dimension of force. Are you getting my point, my dear friends? Yes or no? Now, the case may come where any of these two things will match. So let us say 3 and 4, let us say 3 and 2 are matching. So they have the same term here. If the first term is matching, then you look at the green wala term. The green wala term will be different. Just find out which green wala term is correct and you will get your answer. You don't have to solve both blue and green. First solve any one of them, eliminate the options, and then solve the other one. Are you getting my point? Yes or no? No, yes.
Yes,
This
sir.
is what you say smart hard work. Options are there. Use them. Because if a question like this comes, you'll have to look at the options and then only get the answer. There is no other way out. Can I move on to the next point, beta? Are we done with this? Have you understood this? What I have done here? Anyone who does not understand, please, please, please ask me that out. Because if you have done this question, that means we are doing very good. I will again repeat how I've done this. Information is given to me. I have to find out which of the equations may be correct. I look at the term inside log and I look at the term outside log. Term inside log should be a number. As I can see, there are 4 terms. 3 and 4 terms are similar. Then I look at the term which are outside. The dimension of force has to come from the terms which are outside. There are 4 different terms given there. All the 4 different terms are different. So I only find out the dimension of the outer terms and get my answer. Option number 3, outer terms is matching. Option number 3, inner term will also be dimensionless. You can check it. Therefore, the answer is option number 3. Shall we move on in life? Shall we move on ahead and
Yes,
look
sir.
at the next use of dimension analysis? We have done 3 uses up till here. Use number 1 to convert from one unit to other. Use number 2 to find the dimension of unknown quantities. Use number 3 right now to check whether an equation is correct or not. That takes us to number 4 to find rough. I don't like rough work. To find rough or empirical formula, I call them empirical formula of a given physical quantity. Have you heard the term empirical formula, my dear friends? In chemistry, have you heard this term empirical formula? CnH2n is probably the empirical formula of alkene. Yes or no? We have not heard it. Well, doesn't matter. To find the rough or empirical formula for any physical quantity, it can be done using dimensional analysis. Now, the best way to understand this is by means of an example. For example, we conduct an experiment. In an experiment, it has been found that time period of a pendulum. Have you heard this time period of a pendulum? Time period of a pendulum depends on what are the things on which time period of a pendulum can depend on. Pendulum. This is the gentleman pendulum. What are the things that you think time period of a pendulum depends on? You may know the formula also, but right now we are dimensional analysis. So what are things that you think that a dimension, no, formula for a formula for time period will depend on? It will depend on the mass m of the bob, yes or no?
M of the bob and the length length of the wires, sir, between
Length
the
of
bob.
wire. It also depends on g, which is acceleration due to gravity, yes or no? Because of acceleration due to gravity, this bob has a downward gravitational force, and therefore it may also depend on g. So these are the three terms that are coming into the picture. All three terms are known to us, m, l, and g. Find a possible, instead of rough, you can also write possible to find rough or possible or empirical. All of them mean the same thing. We cannot get the correct answer because of the numerical term. The numerical term cannot be found using dimension analysis. That was the question that came to you in today's class, in yesterday's exam. The numerical value may not be known to you, but we may be able to find out a rough or possible or empirical formula if some things are known. In this case, we are given that it depends on m, l, and j, m, l, and g. From there, you can calculate a possible formula of time period. What do I mean by a possible formula? See, we have already done this question here. Where we had calculated a possible formula for mass. We could not calculate the actual formula because the number wala term cannot be calculated. Are you understanding me what I'm saying, bacha? The number wala term cannot be calculated, but we can calculate a possible formula, and that is what you got to do. You have to derive a possible formula for time period of a pendulum. I can tell you the exact formula is time period t is 2 pi root over L by G. Now first look at this formula and tell me what thing will you be not able to find out? What thing? Which particular thing you will not be able to find out? The thing that you will not be able to find out would be what you cannot calculate. You will not be able to calculate this constant 2 pi, but you can find out the rest of the things, and that is your homework for the next class. You will have to find out a possible formula for time period, and you will have to assume that you don't know anything apart from what is given in the question. And what is given in the question is it depends on three quantities: mass of the pendulum, mass of the bob of the pendulum, length of the pendulum, and acceleration due to gravity. Using this information and whatever we have learned, we will go ahead. I have given you the actual answer. You will not be able to find out the actual answer. Whatever we have known, whatever we have seen, we will be going ahead with the same topic in the next class. And probably by the end of next class or next to next class, by this week, we should be able to wind down your units and dimension wala chapter. So on that note, we would finish today's class. In today's class, we have seen one more use of dimension analysis. We have solved some really good questions in the same language that they appear in the exam, and that is important so that you get a mood or get a feeling that you are solving a question that is going to appear. So I will wind this class here. See you in the next class. Take care. Have a nice day, beta.